Welcome, everyone. We are excited to have you back for the next part of our journey into AI agents and their implementations. Uh, this session builds on the concept we covered in our previous webinar, where we explored the fundamentals of large language models and their capabilities. Today, we are taking things a step further, uh, diving into how AI agents differ from traditional LLMs and walking through the key technical components needed to build and integrate them effectively. Whether you attend the last session or are joining us for the first time, our goal is to provide both theoretical understanding and practical insights to help you implement AI agents in real-world applications. My name is David Kamrowski. I have more than 7 years of experience in AI area. My experience traces back to the times where the most popular neural network was multi-layer perceptron. Things changed a lot from this time. And today we meet talking about something that is almost general artificial intelligence. With me today here is our technical lead in generative AI area, Bartek. Could you tell a few words about yourself before we start?
Yeah, sure, David. First of all, it's a pleasure for me to talk to you again and conduct a webinar for our guests. So it's always a pleasure to talk about AI, especially in terms of AI agents. So this new fresh area in Gen AI. Hello everyone. My name is Bartosz, and I'm a generative AI and DevOps specialist at DStream. So on a daily basis, I focus on building AI solutions that use large language models, vector databases, also various automation tools. In my daily work, I help clients to set up pipelines and frameworks so they can bring AI into their organizations in a practical way. I have experience in cloud platforms, so Azure as my main choice in terms of cloud computing, continuous integration, delivery, modern DevOps practices. My goal is to make AI development faster, and the outcome for easier would make it easier for both small and large projects. Yeah, that's all about me.
Thank you, Bartek. Before we start, let me tell a few words about our company, the Stream, who is host for today's meeting. Uh, at the Stream, we believe that data and cloud technology are the foundation of the modern business success. Since our establishment in 2017, we have been dedicated to helping organizations harness the power of data, optimize cloud infrastructures, and drive meaningful insights that fuel growth and innovation. What truly sets us apart in our adaptability. Business requirements evolve rapidly, and technology never stands still, so neither do we. Our team of over 150 highly skilled professionals, including data engineers, data scientists, and cloud specialists, brings a unique combination of technical expertise and strategic thinking to every project. We work closely with our clients, understanding their needs and designing tailored solutions that are not just effective today, but scalable for the future. Our strength lies in our ability to automate complex data pipelines, streamline cloud operations, and unlock the full potential of advanced analytics. We don't just implement technology, we ensure that it delivers real, measurable value. Whether it's optimizing workflows, enhancing decision making, or building AI driven models, our focus remains on creating tangible business impact. Here we have a slide that tells the same thing I just said in the previous slide, but in numbers. So we have more than 150 professionals that mastered more than 52 distinct technologies and achieved more than 54 certificates. During our 7 years on the market, we delivered more than 120 projects in more than 10 industry areas. In today's session, our goal is to provide a clear and practical understanding of how to implement an AI agent efficiently. We will walk through its architecture, key differences from traditional LLM-based approaches, and best practices for integrating it into real-world applications. To give you a well-rounded perspective, we have structured the webinar into key sections. First, we'll explore the fundamental differences between a standard LLM and an agent-driven approach, why it matters, and how it impacts functionality. Next, we will introduce the technical stack that powers AI agents, giving you insight into the tools and frameworks that make implementation possible. From there, we'll break down the step-by-step process of building and deploying an AI agent, covering the most critical aspects of integration. Finally, we'll wrap up with a summary of key takeaways and open the floor for Q&A. While we have a dedicated session for questions at the end, we encourage you to engage throughout the webinar. Feel free to drop your questions in the chat, and we will address them whenever possible during the presentation. Okay, with that, let's get started. So, before we dive into implementation, it's important to understand the fundamental difference between a pure LLM and an agentic LLM. While both are built on large language models, their capabilities and use cases differ significantly. A pure LLM like GPT-4 or Claude is essentially a very advanced text predictor. It processes each request independently, without memory or the ability to retain context beyond what is explicitly provided by the user at the moment. It doesn't make decisions. It simply generates text based on patterns in its training data. Additionally, it doesn't interact with the external tools unless explicitly prompted. In short, it's powerful but passive. On the other hand, an agentic LLM takes things a step further. It has memory, meaning it can recall information over time and use it dynamically. It operates autonomously, executing actions rather than just responding with text. It can integrate with external tools, calling APIs, running functions, browsing the web, and transforming data. Most importantly, it has decision-making capabilities, meaning it can break down complex tasks into steps and plan actions to achieve a goal. This shift from a static LLM to an agentic system is what enables real-world applications like AI assistants, workflow automation, and intelligent decision-making. Throughout this session, we will explore how to build and integrate these advanced AI agents effectively.
Okay, so let's take a look at a simple example of the difference between a pure large language model and an AI agent. So a pure LLM can answer questions as what is the capital of France and give you an obvious response, which is of course Paris. It works like a smart text generator that uses patterns it has learned in the training process. But if you ask it to book a flight or find a hotel, it will usually not do that on its own. An AI agent, on the other hand, can use different tools or APIs, so application programming interfaces. So if you say, please book me a flight to Paris and find me a hotel, the agent can search for flights, compare prices, and even reserve a hotel. It doesn't just answer questions. It can take real steps to complete task for you. Also, on this slide, we compare various AI systems. So pure LLMs give answers based on text. Chatbots often follow a set script or simple rules, which can be limited, of course. Copilots or agents usually focus on specific tasks, like helping you code or write emails. Agentic systems do a step further by using memory and tools. They can make decisions, interact with services online, and do more than just answer questions. Agents can play a series of actions to meet your goals. They do not only respond to the last thing you said, but can also remember previous steps and adjust when it's necessary. The difference is important because agentic systems can do more complex tasks. They can also work in a more automated way, saving you time and effort. And also, additional slide on our site, you can see a QR code on this present slide. If you scan it, you can set up a consultation with the stream. We'd love to discuss any projects you have, especially if you want to explore AI agents, data engineering, or cloud solutions. Feel free to scan the code now or later, because it will be shown later as well. You can also visit our website for more information about services and expertise. We focus on practical results, so if you have a specific question or challenge, we will do our best to help you find a solution. That's it for my part of the presentation right now, so I will hand things over to David so he can continue with the next slides.
Okay, so as we move closer to our small implementation of an agentic LLM, let's revisit the key differences once more with a stronger focus on what we aim to achieve in the next steps. First, rather than simply generating text based on user input, we want our application to understand the broader intent behind the request, recognize the available tools, and plan the necessary tasks to fulfill the goal. Beyond leveraging the general knowledge the model has been trained on, we also expect it to connect to the external sources when needed, ensuring to access to relevant real-time information. Since many of the tools we'll be using require precise input, our solution will be capable of handling standardized user input and transforming it appropriately. These fundamental differences allow us to move beyond a basic tool that simply responds to questions and toward a fully functional agent one that can analyze messages, interpret requirements, and, for example, find the right flight options that best match user needs. Here we have a broad description of what we're going to implement. We have three fundamental parts of our solution. So first part of our tech stack, core components we are going to use is agent framework. In this case, we are using Crew AI that allows us to orchestrate workflows of agents, tools, and tasks. This is pretty straightforward solution that is very easy to adapt, difficult to master, but it fits our needs for this presentation. Also, we will use large LLM controllers from OpenAI. In our multi-agent solution here, we will use different models for different tasks, so we can manage quality of the answer and the cost of the agent. Second part of our solution is a tool that will allow us to retrieve and analyze flight requirements. And third one is a tool that will allow our agentic solution to connect to the Skyscanner API and search for the flights. To build a truly capable AI system, we need to think beyond a single agent and consider how multiple agents can work together efficiently. This brings us to the concept of a crew, a group of AI agents collaborating toward a shared goal. Within this crew, each agent plays a specific role, equipped with distinct skills and responsibilities. Rather than operating in isolations, agents interact with one another, exchanging information and coordinating actions to achieve a more complex objective. To perform their task effectively, agents rely on tools, external resources such as APIs, databases, and various services that provide them with real-time information, computational power, or external functionality. These tools expand the agent's capabilities beyond just generating text, as we mentioned previously, enabling them to interact with the world in meaningful ways. At the core of this system are tasks, individual actions or objectives assigned to agents. Each agent is responsible for executing its task efficiently, whether that means retrieving data, making a decision, or triggering an external process. By structuring AI systems in this way, We move from a simple single agent interaction to a dynamic multi-agent ecosystem where specialized AI entities collaborate to solve problems intelligently and autonomously. So here is our case. Everyone knows that moment where you are working peacefully in your office and suddenly you receive an email from your boss asking you to go to the New York for the meeting. Well, it will take some time to find a flight, book it, and so on. It's not always easy to determine where really you should book that flight, where you need to go. So what if we had a tool which could get that email from us and simply return us an information what flight is the best one for us? Well, we can use agentic approach for this. Here we can see multiple instances created using Crew AI library that will help us to retrieve necessary information from the email we just received and parse and transfer this information into something that will be useful for finding the flight. So in the first thing we can see here is an agent that will get the email. So we can see we need to define its role, and this is trip flight information parser. Its goal says that it will parse files and extract information necessary to book a flight. Its backstory gives a broader context and behavior details that will execute during realizing the goal. Here we can see we specified that one important thing, that if the flight occurs, for example, in the morning, it should consider finding a flight day before. Also, we ask it to take the distance into the account. There are simple tools given to this agent that will allow it to read the message. So this is file read tool, which doesn't require any specific parameters. This is a strong side of Crew AI, that many things there are automated and intelligent. We specified GPT-4 Turbo, rather expensive model, but we want to be sure that email is read correctly and we book flight to the right place. This agent has one task. So this task is to extract information. We need just a few lines to specify all the details of the task. And the most interesting here is the expected output. So we provide information, what kind of output we want to get from the tool, from the agent, so we can use it in the next tool. If we are unsure if the agent will follow our requirement, we can also attach a Pydantic model that will explicitly specify what kind of data we want to get at the output. So having those like 20 lines of code executed on our email, we receive something like that. So we know that the departure is from Warsaw. We know that we are flying to the New York City. The date is 9th of March, even though the meeting takes place on 11th. So we have a buffer to arrive there and sleep off the jet lag. The number of adults is not specified there, so our agent didn't provide any information. It picked business class as it was specified in the email, and the max price here is 10,000, which is a default we specified. So those values are not perfectly format and type that is accepted by the Skyscanner API, but as we will see in the next slides, it's not a problem for agentic solution.
Yes, exactly. As you, David, said, on this slide, we can see the code that setups an AI agent for searching flights. And think of the flight agent, so the first part of this code, as a virtual travel assistant with a role like a senior flight analyst and with a goal set maybe to find the best flight on Skyscanner. The backstory, so the second part of this function, the backstory just gives it extra knowledge about airline pricing. And when we then give it a search flight tool, so an agentic tool, search flights tool, so it can look up flights like giving the assistant access to a booking website. Settings like verbose equals true helps us to see what is going on, and memory equals true lets it recall past details. Max iteration or max iter equals 5 means it can repeat its thinking process up to 5 times to find the best solution for us. After that, we have a search task that tells the agent exactly what to do, such as turning city names into airport codes or choosing the date. The final output is a simple text with the best flight option. Overall, this code is an example of how we can give an AI agent a clear job, the right tools and instructions, so it can handle real tasks like booking flights all by itself. Yeah, and another part of code. So, code. This one shows you how AI agent talks to Skyscanner to find real-time flight information. When you provide details like where you are flying from, your destination, the travel date, and how many passengers, this tool sends those details to Skyscanner by API. It then receives a list of flights with prices, times, and airlines. Essentially, this is the messenger between the agent and the flight service. The agent says, I need flights from city A to city B on this date. And the tool asks Skyscanner for flight options. Once it gets the results, it hands them back to the agent, which then picks the best option for you. This process happens automatically, saving you the work of searching for flights yourself. And on this slide, we can see a breakdown of how the AI agent thinks and acts. So you'll notice the agent has a step-by-step approach. So the first thing is thought. It internally reflects on what the user wants. The second one, action. It decides which tool or API to use. The third one, action input. It sends a properly formatted request to that tool, so via API call that we presented in the example of Skyscanner. Observation is as a next. It reviews the tool's response. Then, which is very important, this fifth step, repetition. So it may think and act multiple times until it reaches the final answer, because in terms of agentic AI, usually it takes multiple attempts to find the best solution. So this loop, as a result, this loop continues until the agent decides it has enough information to provide a complete response. This chain of thought approach is critical for more advanced tasks. Yeah, and finally, we see the final answer generated by the agent after it's done calling all the necessary APIs and processing the information in this loop process. So the agent presents the flight details, like everything from the airline to the ticket price, just like a travel agent would. This encapsulates the real power of agentic AI, so the ability to coordinate multiple steps and resources, then deliver a coherent final outcome. I hope this gives you a clear picture of how these systems work. At this point, I'd like to hand the presentation back to David for our final section.
Yes, this is how we reach the question and answer part. I don't think that Crew AI implementation requires any additional explanation. It is very straightforward, very easy to play with and try implementing your own solution. So, do you have any questions?
No questions at all. Yeah, but David, I think if there are no questions, maybe we can talk a little bit about implementation of agentic AI. So, as you mentioned, Crew AI is a pretty straightforward and pretty basic Python library. So, what do you think there is a room regarding this Crew AI as being a very nice, very useful tool and very simple Python library? Yeah, I think this question actually I'm answering it right now with this question to you, David. So do you think still there is a room for low code slash no code tools while we having such nice libraries like Crew AI?
It is very difficult question because there is a huge trade-off between creating a fast solution and creating a stable solution. So Career AI at this moment is rather immature. So it is very easy to build a multi-agentic solution, multi-agentic application that will do some stuff for us. But when playing with it, you can see that it is sometimes it is unstable. A lot of the decisions and actions happens beneath the library. So this is in theory this is a strong point of this approach. But when it comes to the debugging, I think it is very important in any generative AI coding process.
Yeah, I don't know if you can agree, but personally, I believe that these tools like Langflow or N8N, which is gaining popularity right now, I think those tools are good for prototypes, for prototyping something. But in terms for pushing something into prod, I think Crew AI is definitely the safer option because, as you mentioned, for example, debugging or gathering logs from production, I think it's definitely easier having custom implementation in Python.
Yes, I totally agree.
Yeah, and we have another one from Mikołaj with the recent news about Perplexity launching their own AI-powered web browser called Comet. Do you think we'll see more companies creating their own AI-based tools and platforms? Yeah, so since David, you answered the first one, I can tackle this one. Yeah, I think probably you are going to see more and more examples of such tools like Comet. But to be honest, I think, for example, deep research from OpenAI already has some kind of agentic tools under the hood, because deep research for sure requires a lot of agentic, custom tools which are doing their job under the hood because even considering the time for the answer, it takes several minutes to complete. In opposite to the all of these chat based applications like ordinary ChatGPT, you're receiving the response almost instantly. But regarding deep research, it takes several minutes. So I believe that because of course it's hidden from us right now, but I believe there is an agentic architecture beneath. So for sure, these agents are working to tailor the response for us. And also, for example, Claude recently released the next iteration of their model. Also, it's some kind of agentic. And I strongly believe that Google, because Google is still, maybe it's not wins the race right now, this AI or AI agent race, but I think position of Google is still very good. I'm pretty sure that Google also will release some agentic tool, like maybe special version of Chrome browser, similar to Comet. Of course, we don't know what Comet will look like, but I can assume that will be similar to all of these ordinary vintage web browsers, but with agentic tools beneath. So I believe that maybe there'll be some kind of special version of Chrome, which is more agentic. I don't know. But yeah, definitely for the companies like Google, Anthropic, OpenAI, still the race is continuing. So I believe there will be more and more tools like Comet from Perplexity.
Okay. It seems that there are no more questions regarding the presentations. So thank you for coming and listening to us. Hopefully we will. Yes. Remember, if you want to consult any idea you have, please feel free to contact us, and either me or Bartek will talk with you and analyze the technical details of your solution. So again, thank you for joining. Hopefully we will see again on our next webinar. Thank you, Bartek.
Yeah, thank you, David, for conducting the webinar. It was a pleasure to talk to you. And thanks, everyone. And see you on the next one.